Hello, welcome everybody to my session from single MySQL instance to HA. So this is what I call the journey to MySQL InnoDB Cluster. So thank you for joining this session at FOSDEM. So let's start with who am I, right? So my name is Frédéric Descamps. I am known as LeFred. You can follow me on Twitter if you are looking for MySQL information. I am MySQL evangelist, so I'm part of the MySQL community team. I'm managing MySQL since a lot of time. My first version I installed was 3.20. I'm a DevOps believer living in Belgium, and I have a blog where you can find a lot of information related to MySQL called lefred.be. And as you can see, the hairdresser are still closed in Belgium, so I apologize for this haircut right now. So evolution to HA, right? So this is what we are doing today. So we start from a single instance to full HA with using MySQL. So the start, it's made by a single MySQL instance. So this is, you just install MySQL and you're using MySQL. Some tips that are very necessary if you don't want to lose data when there is a power cut or something like that. It's to exclusively use an ACID compliant storage engine. So in our case, it's InnoDB, and keep the durability to the default. So meaning that you are writing in the InnoDB logs files all the transactions that you perform. So at least when there is a crash, you do the crash recovery and you don't lose the data that has been committed. So we are running with one machine. We are very happy. Everything works as expected. But what's next? So next level, it's that our database becomes more and more important, and losing it, losing the database might be an issue, right? So what can we do, and what do we need to plan, right? And to do that, we need to put some targets, and these targets are the RTO. For start with, we're gonna put hours, and the RPO to 1 day. What does that mean? So these RTO and RPO are some metrics that we use to design an architecture for our database, right? And RTO means the recovery time objective. So how long does it take to recover the service? So how long does it take me for the service to be up again and be usable? And the RPO is the recovery point objective, meaning defining how many of data can I lose, the maximum of data that I can lose. So the RTO, to start, we do the RTO hours. So we have some hours to recover and set up again the system. And RPO, it's 1 day. We can lose 1 day of data at max. So when we have these targets or these goals, what are solutions? The solution, it's very common solution known by everybody, but not deployed by everybody. So warning here, please, if you don't do it, and do it now, and certainly before an upgrade. This solution, it's backups. You need to have backups. Physical backups, there are commercial version, open source version. In MySQL, we use MySQL Enterprise Backup, and logical backups, that it's just a logical backup that you can restore everywhere. And the logical backups, usually people are doing MySQL dump. Please try to avoid MySQL dump as much as possible and use the new MySQL shell dump and load utility, which is much faster, much convenient, and you can use it to dump schema, dump a full instance, and also to migrate this instance to the cloud, for example. It works perfect with OCI. So now we are happy. We have this MySQL instance. There is durability. If there is an issue, we have a backup. We can recover. It takes time to recover the full backup, of course, and we can lose data. But 1 day of RPO, that's a lot, right? So if we want to reduce that to minutes, you know, I can lose data, but 1 day, I agree to lose some data, but not too much of data. So I will change now my goals, my targets. So RTO, so I still have a lot of time to recover, but I don't want to lose much of data. And here we need to concentrate on 2 issues, right? First issue would be, for example, we have a human issue, a user that has SQL access, do delete star from table blah 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 and forgot the where clause. Poof, it deletes all his data, right? So in this case, how can we recover the data? So we need to use binlogs and have durable binlogs, of course. Durable is always better. So meaning that when it's committed, it's written on disk and we are sure we don't lose them. So this is default in MySQL 8. So we have log bin on and sync bit log with on. Watch out, reducing durability, meaning you are losing durability. So this seems strange, but it's the fact, right? And it's common. So now we have that binary log. So our user make a delete. We can restore our backup and then replay these binary logs. So these binary logs are files where all the changes on the database are stored and can be processed later by the DBA, because InnoDB logs, the DBA cannot do anything with it. So this one the DBA can use them. So the next level is that my data is still very important. It has a heavy workload, and I want to lose less than a second of data. So minutes, but now it's even seconds. And not only that user that does something stupid, but also that there is an issue on the system, or a system engineer does something stupid, could happen too, that it deletes data directly on the MySQL data directory. I've seen that already. People goes there and say, oh, this is a big file, let's delete it. And it's a very bad idea. So now RTO hours, RPO less than a second. We don't want to lose data. How can we do that? So we have to, of course, still, if we don't want to less than a second, we need to have this durability here. It's very, very important. So we need to have the durability. We can enable GTID. This is not mandatory, but it's optional, and it's much convenient, certainly for the next steps later. And this is where it's also important, is to offload the binary logs in real time. So how do we enable GTID? So first thing to do is to specify or to see if we can restart or not MySQL. If you can restart, it's easy. You do set persist only GTID mode equal on, set persist only, and force GTID consistency equal on. These two variables needs to be enabled. As you can see, I don't modify my CNF manually. I do it from the SQL using MySQL 8. So in the MySQL mode, I do set persist, and MySQL does all that for me. And it's very convenient, these settings, these commands when you are using the cloud, for example, where you might not have MyCNF access, right? So this is when you can afford a restart. If you don't want to afford a restart, you can do modify the GTID mode progressively. So the first thing to do is to do set persist and force GTID consistency equal on. As you can see, I don't do persist only, but I do set persist. So I modify the running value too. And then I modify the GTID mode from off to on, going step by step to off permissive, on permissive, on, and finally, right? So this is how we do that. You modify that without a restart of MySQL. Then we want to offload the binary logs, and to do that, we're going to create a dedicated user that will be used to do that in MySQL. So we're going to create this user. In my case, I call it getBinlog. You will give it a password. We say, okay, let's use SSL. Then we will grant the replication privileges we need. And finally, on a dedicated machine, what we're going to do, we're going to use the MySQL Binlog program to stream and read from the remote server and stream all the binary logs there on the file system. Of course, this is the command. The command, you can make it better using a systemd script or whatever you want, with loops, checks, but this is the basic, what it needs to do. And when you have that running, all the binary logs are streamed live to another machine. So this is very useful. After that, if you have an issue, you can do point-in-time recovery. And if you want to do it faster, if you have a lot of data to process, because there is a heavy load, for example, in your system, this is a blog post that explains you how you could do it much faster in parallel. Please go to read it. I invite you to read it. So this was, now we have this MySQL server single instance. We are doing backup somewhere. We are saving the binary log somewhere else. All it's durable. We are very happy. Now my service, it's more and more important. So my business is going well, my application is going well, and I need to pay even more attention to MySQL. And because when we are down, we are losing money, I want to be up much faster than in several hours. How can I do? So I want to reduce my RTO, my recovery time objective, to minutes. RPO, less than a second, it's quite fine. Let's do that. So the next step to be able to achieve this is to use MySQL InnoDB ReplicaSet. So MySQL InnoDB ReplicaSets are based on the native asynchronous replication known by a lot of MySQL DBAs, right? So this is where we use binary logs that we have enabled earlier, where we use GTID that we have also enabled earlier, and stuff like that. But it's easier, and easier, it's better, right? So let's see how we can do that. It has data provisioning included using MySQL clone. So this is wonderful. Because sometimes I've seen that a lot of people, the issue they have with creating replicas, it's how do we provision the data the first time, right? So now to provision the data, you don't need to take care of it. ReplicaSet, it's all built in, and it will take care of it, and it's very convenient. Of course, you can have 2 or more nodes, but it has a manual failover, but not an issue because we have minutes to recover, so it's okay. And it has transparent automatic query route routing using MySQL Router, right? So with MySQL Router, you will have different ports, and depending where you connect to, you will do writes or you will reach a read-only server. So the architecture looks like this. So you see we have a MySQL shell that orchestrates everything. You have MySQL replication there with the instances, and you have a router that the applications connect to reach the database. So now, from that single instance we have, if we want to move to InnoDB cluster, InnoDB ReplicaSet, what do we need to do? So on the current server, what we do is, first thing we do, configure ReplicaSet instance. So we do DBA. DBA is the global object in the shell that allows you to use the admin API. As you can see, the shell here I'm using in JavaScript. So JS means JavaScript. You can use the shell, MySQL shell in Python or in SQL mode. So now I do configure ReplicaSet instance. It will check my instance if there is something missing are the Binlogs there, it's the GTID enabled because this requires GTID. So it checks all that, and also it checks the user you are using to connect to it. And usually by default, where you just install a server, you are using root, and it says, okay, root cannot connect from everywhere. Do you want me to change that, or do you want to create a dedicated user for that? I always recommend to use a dedicated user for that. So when you have done the configuration, you do the DBA create through ReplicaSet, and you put the output of this ReplicaSet inside, you assign it to a variable, and the variable, I call it rs, but it's whatever name you want, and you give it a name, and the name of my cluster, it's of my ReplicaSet, it's my ReplicaSet. Now you just install another MySQL server, right, with the shell, and on that machine you just do DBA configure ReplicaSet instance again. It will do check for the user, ask you if you want to create a new user or not, and make the modification. And when it's done, on the primary, so the single instance we had earlier, where we create the ReplicaSet, we do add instance, and it will add the instance for you, and it will create that ReplicaSet. So when on the new instance you do configure ReplicaSet, ReplicaSet instance, this is what we have. So it says, okay, we want to configure it. It's a bit small on video for sure, but you will have the slides also. So it says, okay, which user, what do you want to do with the user? Like I said, we always recommend to create a new one. So we're going to create a new one, option 2, and we do give a name, and the name is cluster admin. So we do cluster admin, we give a password, and then it says, oh, and for GTID consistency, it's not enabled because it's not the default in MySQL 8. GTID mode is not enabled. Do you want to enable it? And server ID, every time you install MySQL, server ID is 1. It says, do you want to make a very unique value? You said yes. Then it says, I will do the change. Do you want me to restart MySQL for you? You said yes. It's all done. And the next step, when you do add instance, it will tell you, okay, now we need to do the provisioning of the data. So what we call the recovery method. And it gives you the possibility to do clone, incremental recovery, or abort. Clone, it's what you should do there. Incremental recovery, meaning it will play the Binlogs from the beginning. But almost nobody in production has the binary log since they created the server on the same server. So I use clone, please. You do see it does that for you, and as you can see, it works perfect, very fast in parallel. And what does clone? So it makes this kind of snapshot of all the data from the source and send it to the replica using the shell, and you no need to open different ports and stuff. It's all go there using the SQL port the MySQL port very easy. So when we have created that, it says, okay, the instance now it's added. What you can see, we can do status, and on the status we can see that our ReplicaSet it's available, and that it has MySQL, single MySQL, so it's our first server, first instance we created, that is read-write online and has the role primary, so it's the second on the screen, and the first one on the screen is the new one we have added, that is secondary read-only, right? Perfect, and it uses asynchronous replication. So now we have this single instance where we can write data, the other one where we can read data out of it, and where we can use in case of an issue. Then the next component that I was explaining for the full solution, so the shell, this is what we used to orchestrate and to create all that. MySQL, we have done that, and it was the router. So on the router, we need to bootstrap. So on the machine where the router is, you do MySQL router, bootstrap, using the credential where to connect, the system user to use, so in this case MySQL router, so this is the operating system user, and it will bootstrap, make all the configuration for you, and you can start it and use it. It's done. It tells you here, for the classic protocol, you need to use the port 6646 for read-writes, for read-only 6647, and for X protocol, the same with different ports, of course. So now in the shell, now that we have created routers, in the shell you have the possibility to see which router you created. So you can do list router, and you see them here. You can see, oh, we have one router in ReplicaSet. So now that we have this ReplicaSet running, when an issue happens on the primary node, what do we need to do? Like I said, we have manual failover, meaning you need to monitor what's going on. You need to know that you have an issue. It's not a big issue because we have some minutes to recover the service when it's done. So when it's done, your pager needs to tell you, oh, MySQL primary node is gone. We don't have MySQL. Please do something. So here we are connected to the ReplicaSet using the router. We do status, and it says, okay, you have a primary issue. The status is unavailable. You need to perform something. So what is the something? The something is to force the primary instance. So we're going to migrate the role primary to the machine that it's still up. One of the machines that is still up. In our case, we have single MySQL and MySQL 2. So MySQL 2 needs to take the lead. So this is what we do. And as you can see, failover, it's done very easily and quickly. So this is easy to do. The only thing is that it's manual and then you need to check. And we cannot do it automatic because we are using asynchronous replication. We have no idea of the network partition, quorum and stuff like that. All that, it's maintained and it's managed by group replication, for example. And this is the next level. The next level, my service is very important. I would like to be always up and to have this automatic failover and never lose data. How can I do that? So the objective have changed now. The RTO become seconds because we want it to automatic, so that we don't want to page somebody, takes the time to connect, blah, blah, blah. No time for it. And the RPO 0, we don't want to lose data. Do we have a solution for it? Yes, this is MySQL InnoDB Cluster. So MySQL InnoDB Cluster is based on MySQL native group replication, but it's easier. Like I said earlier, easier is always better. It has data provisioning included, clone again. You need at least 3 nodes to make this automation and or more, but you always use a odd amount of nodes to avoid split brain situation, of course. It has automatic failover, like I said earlier. We again use router, and we have consistency level that are configurable for session globally to avoid store reads if it is an issue for you. We can. There is a lot of possibility in consistency level. I will be glad to answer questions if you have questions on that later. And this is the architecture of the InnoDB cluster. So we have the router, we have the servers that replicates using group replication, and the shell to orchestrate all that. So how do we migrate from this single instance, from this ReplicaSet to InnoDB cluster? What we do, so the first thing on the primary of the ReplicaSet, we will do drop the metadata schema, and then we will create the cluster. Then on the secondary instance, we do in SQL stop replica, reset a replica to forget about that. And then on the primary node, where we have this cluster object we created, we add the new instance, the previous instance. We do add instance MySQL 2, and it's added. And now on the third machine, so a new machine we just installed, we do configure instance, get cluster again on one of the machine where we have the cluster, and just add that instance. And it will do everything automatically for you like magic, and it's perfect. Then don't forget the router we had. We need to bootstrap it again using group replication and InnoDB cluster, and we need then to force the writes in the configuration, and we can restart it, and it's up and running. So we can do InnoDB cluster status, and we can see that we have a cluster running with 3 nodes, and all it's healthy online, and we can tolerate up to 1 failure for automatic failure. So 1 node crash, no problem. Another node crash again, then manually you need to decide which one has the lead because of the split brain situation that could happen, right? So what's next when we have that? So the next step is, for example, to have this InnoDB cluster and have an asynchronous replica for disaster recovery somewhere else. And to do that, we have asynchronous replication source connection failover in 8022. So something we have added. We have a list of servers that if the source is not there, is not available anymore, the replica will select another source from that list. In 8023, that list is updated supporting group replication. So that's very easy to do. You could have also a delayed MySQL replica somewhere, just in case you don't want to do point-in-time recovery too much, or you want to find data a bit from the past, so some hours delayed, for example. And also you could have MySQL InnoDB cluster with an asynchronous group replication node somewhere. So this is possible. It's more complicated, but it is possible. And of course, more to come in the future. As you can see, the MySQL team, HA, Shell, replication, server, we're all working to improve that more and more and to give you a solution more and more. So I think it's time for questions. We'll be just there to answer your question. Thank you very much, and waiting for your question.